All right, welcome. This is page 9 of your notes. We are working on kind of putting it all together. So what I mean by that is you've had some functions that are honestly pretty basic. You did, 1, 2, and 3 yesterday. 4 got a little bit more involved because you had to factor the denominator. And that was on page 7. But now it's like, what happens when you have a little bit more going on in the numerator and denominator and we have to do all this stuff? So there can be quite a few pieces going on. Nothing really changes except you're going to have to do some factoring and factor. And you're going to need to find holes like we did before if they exist. So remember, a hole is when you cancel out. A hole will exist. Remember, a hole exists when you cancel out the same factor on top and bottom. So really, you would focus on graphing this and you would figure out where your hole in the graph is. So initially, we need to factor and do like master product sum. So x minus 3 and x plus 1, x minus x plus 6, and x minus 1. Okay, so again, when I looked at the hole in the graph, you would cancel out the same exact factor, but I don't have anything that cancels here. I have a plus 1 and a minus 1 in one of the factors, but those don't actually cancel, so we need to leave them alone. So there's going to be a little bit more involved in the graph. All right, vertical asymptotes, I'm going to skip down to verticals first because those are always the denominator equal to 0. So find the vertical asymptote by setting denominator equal to 0. So I said x, so I'm looking at the denominator of x plus 6 and x minus 1. I said both these pieces equal to 0, so x plus 6 equals 0, and x minus 1 is equal to 0. So x equals negative 6, and x equals positive 1. So you did have a, sorry, on page 7 you had, number 4 you had a graph with 2 vertical asymptotes, and it is possible that you can have more than that, but sometimes they're not always even, so it's not always like a 2 and a negative 2. Or a 1 and a negative 1. So we have a negative 6 and a positive 6. So my vertical asymptotes, make sure you write them with x equals negative 6 and x equals positive 1. So on the graph. Okay, 1, 2, 3, 4, 5, 6. Okay, so if you were using highlighters, feel free to do that. Make a solid line. If you don't have one, that's okay. Not a big deal. Try to make it like stick out somehow. So if it's going to be a marker, if it's going to be, if it's your pencil, that's fine. Just make a solid dash line. If you just want to make it dash as best you can, that's fine too. All right, horizontal asymptotes. That's when we compare the degree of the top versus the degree of the bottom. Let's see. So for the degrees, I'm actually going to look back at my original function and once it was multiplied out because I want the total degree. So the horizontal asymptote, I have my degree of my top is 2, the degree of the bottom is 2. So the horizontal asymptote, I take the leading coefficient, which means I take the number in front of that x squared and the number in front of that x squared and make them into a fraction. So y equals 1 over 1 or just 1. So that's nothing new because degree of top equals the degree of the bottom. All right, so the more recent thing is let's get the intercepts. All right, so the top intercept, so let's find the x-intercepts by setting the top. I'm sorry. Set the numerator, the top equal to 0 and solve. So I'm going to do that as easiest way possible. Now I have two versions of the top. I have the non-factored part, so I could do x squared minus 2x minus 3 equals 0, or you could do the factored part, and I think honestly the factored part will be easier because I must set those equal to 0, so do each one. So x minus 3 equals 0, so x is a positive 3 on the x-axis, so 3 comma 0. And the other parenthesis, I have x plus 1 is equal to 0. So x equals negative 1 is the second x-intercept. All right, so let's find the y-intercept. So every x changes to 0. So anything that has an x. So again, you can use either version of this you want. If you want to do the original one, x squared minus 2x minus 3 over x squared plus 5x minus 6, if you want to use that one, that seems easier to plug in x for. It might be. Or if you want to do these and do 0 minus 3 times 0 plus 1, either's fine. All right, so every x changes to 0. So I have 0 minus 2 times 0 minus 3. So everything that has an x cancels out to be a 0. And then I have a 0 plus 0 minus 6. So I have negative 3 over negative 6. So negatives cancel, so positive 1/2. All right, so for the y-intercept, it's 0 and then 1/2. All right, so on my graph so far, I have two vertical asymptotes. I have a horizontal asymptote at y equals 1. Oops. Y equals 1. I have x-intercepts on the x-axis at 1, 2, 3, and then negative 1. And then I have a y-intercept at 0 and 1/2. All right, so we got to figure out some behavior because I got to figure out what's happening in the left part of the graph. So I'm over here, I got to figure out what's happening in the middle part of the graph and figure out what's happening on the right side. So yeah, it's just some points. So you can figure out some behavior. So this talks about like the x value of the first vertical asymptote and a point to the right of the vertical asymptote to determine how it behaves outside of it. So the vertical asymptote is at negative 6. So I'm going to plug in negative 7. All right, again, you will have these calculators to use in class and that sort of stuff. You cannot take them outside of class, but you will not be allowed to use any graphing calculator on a quiz or test. So why we'll have them, they function. You did use them last year in geometry. They're the same calculators. They function the same way. So I want to plug in negative 7 and see where I'm landing. So let's see, negative 7. Plug it into your function. Remember, these have, if the mode is in the math print, you can use these nice things called fraction buttons. Plug in negative 7 squared minus 2 times negative 7 minus 3. And then, or you can plug it into the parentheses. Either way, it's fine. Make sure when you plug in negative 7, it's in parentheses by itself, times negative 7 minus 6. All right, so I got 15 over 2, which is 7.5. So negative 7, and let's see, 1, 2, 3, 4, 6, 7 and a half. All right, so you can see kind of your graph is going to be up here going up that way. So when I'm asking for yesterday, if you were in class, you need 3 points in each section. So you need to get 3 points over here, 3 points in the middle, but you already have 2, so just need a third one. And I can tell you this one is going up like this. Now, how you can tell is if you want to, you can plug in 0.5 there. Okay, so this is for some other stuff which we're not going to even worry about. So really, I want you to plug in points and figure out what's happening. So if I plug in 0.5 for this other one, because I'm worried about what's going on inside the asymptote, I have a general idea for the other two. What's going on? So I know over here, my value should be up above here. My 2 points here are leading me here. My third section, I'm going to have it potentially down there. So you just need to get some points. So like 0.5. And I'm going to try the factoring part. 0.5, oops, fraction, right? 0.5 minus 3 times 0.5 plus 1. See? Maybe I shouldn't do this one. Okay. Okay, the bottom part, 0.5 plus 6 times 0.5 minus 1. Alright, you can already see if you do 0.5, my calculator, while it may not be pretty, it's giving you something above 1 for the value. So 0.5 is here, 1 and a little bit above is right there. So it is going through the horizontal asymptote, which it can do. It doesn't do it all the time, but it does it if it's close to the origin. Now, it doesn't do it every single time you see it, but it can do it. So don't be totally thrown off if it does. This other part of the graph goes like this and goes down to that asymptote. Close to it, but not touching it. You can never go through a vertical asymptote, only the horizontal close to 0. All right, so pick some other points. I need 3 points to have the middle section done. I need some other points to the right of this asymptote. So this asymptote is at 1. So like maybe 2 and 3. Oh no, I got that wrong. 3 0. All right, so maybe 2 here, and then maybe 4. So figure out what's happening at 2 and at 4. 2, h of 4. And then on the other side, so I'll have my 3 points there. And then if I did -7 already, maybe -8 and -9 and see where they're getting me. I am going to post this, what the final graph will look like. I'll post it on Classroom. So go ahead and figure out what those points are. So type them into your calculator. If you have the graphic calculator now, fantastic. Just type it in like you're trying to do the calculation. You just won't be allowed to use that in class. Talk to you later. Thanks. Bye.